My name is Fiset-Algarvio, and this is project POV Globe. So first off, you got the DC motor in the middle that spins the frame counterclockwise, which is connected to this 38 ESC controller, which is also connected to this adapter, which supplies 9 volts and 2 amps, and the ESC is also connected to the Arduino Uno, which is connected to the potentiometer, which determines the speed of the motor. So if I turn the potentiometer counterclockwise, the motor will spin with increasing velocity, and if I turn it counterclockwise, then the motor will slow down and then come to a stop. Now, over here on the frame which is what the motor spins, I have the Arduino Nano with a 3.7 volt 9 LiPo battery. I have 8 LEDs, and I have a special sensor called a Hall sensor, which senses magnetic activity. So I have a magnet at the back. And so how this one part works is that the Hall sensor calculates the time it takes to make one full rotation. So it calculates that time, turns that time zone into 360 degrees, and then it sends that signal to the Nano, and then the Nano will choose the locations of when each of the 8 LEDs will be on or off at specific locations of time. So of those 360 degrees, the LEDs will pick 2 degrees of which they will be on or off. So it could be on, they could have been on here and off here, and on here and off here, and then keep doing that cycle, and it will repeat that all the time. And when it does that full cycle, it'll make it look like a text appears. Here is my code for the POV Globe. So here's the motor code, and here's the LED code. So we'll start with the motor code. First off, I have access to the servo library, which is the motor library, and then I set a variable for the servo, or for the motor, and I've also set a variable for the analog pin, so the potentiometer pin. I've set the motor pin to be output, and then over here I've set the val. So the value of val is going to equal the value of the potentiometer reading, and then val is going to val is equal to that. So it converts the potentiometer reading to motor reading, and then it displays displays the motor reading, and and then after delay 15, it repeats that all day long. And while it spins, I have the LED code, so I have every letter from A to Z, plus period, apostrophe, question mark, and space bar. I've set some more variables for timing of when LEDs should be displayed. I've set outputs to 0 to 7 and an input for pin 13. On the Nano, I've made a line function where it will display when each LED should be on or off for each line according to the letter. And then I've set each letter, so every code is the same. All these codes are exactly the same, except for each letter of the alphabet, including the apostrophe, question mark, period, and space bar, with a delay. And what else? And over here is the loop function, where it will calculate the time it takes to make one rotation, and then find 360 degrees, and then make the lights turn on and off according to that 360 degree time zone, which is according to the speed of the motor. So right now, and what it will display is this code. So it'll display this exactly. So RSGC would be on the front, where the magnet is not, and ACES would be at the back, where the magnet is. And yeah, that's my code. Now let's see my globe in action. So I'm going to turn this potentiometer. You have RSGC on the front, and you have ACES on the back. Now let's see it in the dark. There you go. You have ACES in the back, in the dark, and RSGC in the front. And that's my POV globe. Thanks for watching.